Good afternoon. Nice to see quite a few of you back after lunch. Thank you very much for coming along to this session on smart grids. My name's Martin Hill. I'm the Future Networks Manager at Scottish Power Energy Networks. Just to set maybe the context for this session this afternoon, around about maybe 12 months ago, along with Scottish Enterprise and a number of the panel members here today, we kicked off a smart grid sector strategy to really look at what were the opportunities, recognising that Scotland really is one of the leading areas in the world in terms of smart grid and some of the developments that are ongoing, and how can we maximise the opportunity for Scotland in terms of developing the supply chain, the opportunities for SMEs, given the very strong platform that we've got. So I'm just going to start off myself giving a very broad context to smart grids and the opportunity that exists, before handing over to Stuart Reid from SSE, who's going to talk about some particular demonstration projects that have been ongoing over the last few years and the opportunities that this has created for the supply chain to help that develop. We'll then be passing on to Ileana Portuguese, who's the Director at the Power Network Demonstration Centre, which is very much one of the leading demonstration centres for smart grid technology, I think it's fair to say, in the world, and talking about how that platform is being used to help de-risk technology and help to promote that supply chain. And then finally, we've got two presenters, Alan Gooding from Smart Grid Solutions and Joss Traherne from Symmetrics. I think two very good examples of organisations that have started up in Scotland and developed within the UK and now looking to expand internationally within this arena. So, in terms of the role of networks, obviously networks, one of the key enablers between meeting or facilitating the low carbon transition. And over the next decade, this requires quite a substantial investment across Scotland. It's expected there's over £10 billion of investment required in the electricity networks in Scotland alone. It's quite a sizable number for, I think, something which all too often I think is forgotten about, but is very instrumental in facilitating low carbon transition. From the expansion of the network, obviously in the 1950s, 60s and 70s, all of that infrastructure that was installed then is now reaching almost its end of life and requires to be upgraded, modernised, replaced. And in doing that, obviously it's vital that we keep the lights on. How do we modernise this asset base? And probably most importantly, and why we're all here today, how does that network then facilitate the transition to a low carbon economy in the future? One of the things that's you're probably already familiar with and why you're here today is to hear about smart grids. Smart grids, I think, is used in so many different contexts, but I suppose maybe to try and put a definition onto that, smart grids very much about employing a range of new approaches, particularly how we use communication, innovative products and services with intelligent monitoring and control technologies on the network, all with the end purpose of facilitating new generation onto the network. We're changing the way that electricity is generated from central hubs to being distributed across the network, enabling greater demand-side participation so that the demand and generation are better matched, aiding this overall system balancing. What was previously just a task carried out by the National Grid is more and more something that needs to be carried out by all of the network parties. Actually empowering customers to be more informed of some of the choices that are available, reducing the environmental impact of the network, for example, the amount of overhead lines that are having to be constructed to facilitate the renewables, what alternatives are there out there, and most importantly of all, ensuring that we have a reliable, flexible, high quality and secure system for the future. In terms of trying to define almost what the key components are that make up a smart grid, there's almost no getting away from the core network assets, the backbone of the network, the transformers, the cable, the switchgear, almost the things that we've done for such a long time. But very much the other components are the new elements which make the grid smarter. The communication platforms that sit over this, for example, radio systems and power line carrier technology. And using these communication systems then to acquire data from the various monitoring and sensing that's out there. For example, how do we use smart metering data that comes back to make the grid smarter in the future? And then processing all of this data in IT systems as we've never used before, and learning from other sectors where similar intensive IT data processing already goes on. How do we use that to make more informed judgments about how we operate the network? And almost sitting behind all of that, the new technology which this will facilitate: active network management, dynamic rating of our assets, high voltage DC interconnections with other countries, energy storage. There's a variety of other technology there which is really untapped, which we'll be looking to explore, and that are new markets that are not mature by any means, and we see it as a key opportunity to encourage development within the supply chain to help us make this transition. I'll hand over to Stuart to talk about some particular examples of projects where this has been demonstrated now.
Thanks, Martin. Bang on 5 minutes, as promised. What I want to do here is just, I think the best way to demonstrate what is capable. Here we go. One of the best ways of demonstrating what we're capable of doing with Smart Grid, and also the opportunities to actually talk about some real projects that are underway at the moment in Scotland and more broadly in the UK. So there's 4 projects I want to use as kind of a case study, and the first one is the Nines project, which is up on Shetland. And just to kind of let you understand first the challenge on Shetland, Shetland is not connected to the mainland by an electrical network, but it is part of the UK system. So customers there can buy and sell electricity at the same price and so on as the rest of the country. And there's a large diesel power station up in Shetland, and 7% of the generation in Shetland comes from wind. Now, the problem we have on Shetland is, despite the vast amount of renewable resources up there, we cannot connect any more wind because the proportion of wind is so great. It's like, you know, a dog, the tail starts to wag the dog. The diesel engines don't have enough control left because they're getting squeezed out by the wind coming in. Yeah. So the conventional way to deal with that, if you like, in a sort of more traditional smart approach, is just to pile loads of energy storage in and store the energy when the wind's blowing and put that back in. But the problem with that is it's a very, very expensive solution. And you've also got a situation in Shetland where you've got an area with a very high proportion of fuel poverty. So what we've done on Shetland is try and find ways in which we could actually balance the system without actually using things like batteries. They play a role in it, but using more demand-side response. And what demand-side response, you see on the right-hand side here, we've got pictured 2 components: a storage heater, as you traditionally know it, and a hot water tank. Now, what we've done on Shetland, working with Dimplex, and this is the first pointer here, Smart Grid extends beyond the meter. So it's the first learning point here, yeah? So this is Dimplex. I've got a new production line set up in the back of the work we're doing here to produce these new units. Now, what we've done is, with Dimplex, enhanced the storage capabilities of storage heaters, and they've called them a quantum heater. So we can actually store and enhance the amount of energy within these heaters for a longer period of time. Another thing we've done is redesigned the traditional storage, hot water storage tank in a house. So we can actually inflate the temperature in the tank to store more energy in it. So we can get about 5 or 6 kilowatt hours worth of additional energy into a hot water tank using this process. Now, the key point for us here is that to buy 4 kilowatt hours worth of batteries or 4 kilowatt hours worth of capacity in the power station would cost several £1,000, £5,000–6,000, especially when you take the life cycle of the batteries into account. To do it with a hot water tank is obviously significantly lower cost, and it's an asset that the customer has already. And the key point is that we're able to recognise the value of that storage asset in the customer's home. So what we're doing in the model in Shetland is actually paying an ancillary services payment, making a payment to the customers for the privilege of being allowed to store energy in their assets. And we're doing that instead of actually buying a battery. So not only do we actually avoid the significant expenditure on energy storage devices, but we also actually return that value back to the customer. And you can imagine you create a virtuous cycle there in terms of value, in terms of fuel poverty and the cost of operating the network. And the other part of the value chain is the other thing we can do by doing that. We can get more renewables into the network, a lot of medium, small-scale units, so the communities start to be able to earn FITs, and some of the larger commercial properties organisations start to be able to earn incomes which help the economic growth. So you create these virtuous cycles within the project. And this is where it's important to understand that Smart Grid is not just about communication systems and big IT systems. They're needed to enable this in some cases, but it's about beyond the meter. So there's massive opportunities going ahead. There's a £500 million per annum market in ancillary service in the UK at the moment. And that's what's being done here. We're using demand-side response to provide a slice of that market. So you can imagine there's a lot of value in that as you go forward. So redesigning products, redesigning industrial processes to take advantage of demand-side response is a big thing, I think, in terms of moving ahead in this. So the other things we're doing, we do actually also have a battery on the project because we think it's important to understand the full portfolio of technologies. And there are circumstances where things like batteries are the only option, where you don't have the demand to manage and so on. So we've got a battery in the project as well. And the bit I like the most, there's a district heating system up in Shetland, and what we've got there is a very, very large hot water tank that stores energy in the form of heat that's used later on to heat the district heating scheme. What that actually means is the wind can be blowing on Monday morning, and we can store up to 130 megawatts, it says 150, it's 130. 130 megawatt hours worth of energy in the form of hot water on the Monday, and we could be heating homes the following Saturday. We lose 1% of energy per day in the interim period as well, so it's a very efficient way of storing energy. As you can imagine, significantly, a factor of 20, cheaper than other forms of energy storage. So you can see the sort of opportunities here are about thinking laterally about energy storage and thinking laterally about the opportunities. So what else could you do in your process? If you've got an industry that has a lot of energy passing through it, how could you redesign that process to be taking advantage of these sort of markets and helping to balance the UK system? So the other example, which is actually one based down in Thames Valley, was one of our projects, is the Thames Valley Vision project, and this shows kind of the other end of the issue that we have in terms of smart grid. Thames Valley is not a particularly windy place. We don't have a lot of renewables being connected there as such, but there's obviously solar and the likes, and a lot of the systems are going on in the LV network. So on the network down there, it's issues like the connection of electric vehicles, issues like the relatively small input of energy from solar arrays. There's the harmonics that you get off these sort of devices. So it's about power quality and getting more capacity out of the low voltage network rather than the Shetland one, which is looking more at system balancing overall. Yeah. So what we're doing down here, this is where you see the more traditional kind of view of what smart grid would be. We're putting monitoring systems into our network so we can understand the power flows in our network, so we can get more headroom out of them. It's a key point to make here that the traditional way we manage our networks is if there happens to be a 1 hour long peak at some point in the whole year, that means our network's going to be overloaded. We will build a bigger network for that 1 hour peak. That's what we do. That's the norm. And what we're trying to do with this model is actually remove that peak and plan in 3 dimensions. So actually take, is there another way you can deal with that 1 hour peak in order to avoid the need to invest in the network? And that applies for demand and generation. So, for example, electric vehicle charging. One of the projects we're working with at the moment, a company called EATL, is a simple device that allows the staggering of the charging of electric vehicles through the night, so that you don't end up with everybody plugging in at 5 o'clock and overloading the network. There's some really simple bits of technology, and interestingly, at the other side of the meter, not on our side of the meter, they're actually enabling us to actually apply smart solutions to the problems that we're having on the network. So monitoring a big piece here. Now what we're doing in the Thames Valley project is, we mentioned about taking learning from other sectors. What we're doing here is taking the sort of things that Tesco's would do with loyalty cards and seeing if we can understand the nature and characteristics of customers' behaviour. Now, not for any clandestine purposes. The reason we need to know that, if you can imagine, if you have devices like energy storage devices, demand-side response, that 1 hour peak I was talking about earlier on, you need to know when that peak is going to happen. If you get that wrong and you, let's say, discharge your batteries 2 hours before the peak actually happens to actually address it, you've shot your gun. Yeah, it's gone. You can't then use that asset to actually manage that peak. So being able to forecast what's going to happen in demand is really important. Now, you might say, well, that's something that National Grid have been doing for years, and they have, but they've been doing it with very, very large populations. You're talking about millions of people or hundreds of thousands on a particular grid point. What we're talking about is streets. So how on earth do you predict the load profile in a street with 20 people in it? And what sort of things change the nature of that profile? So a lot of work we're doing there with the University of Reading, so a lot of analytics going on there, a lot of data processing. This is where you start to see the IT piece come in, and where you start to see opportunities for kind of cross-sector fertilisation of ideas. That nicely leads into the modelling obviously, with that data and with that knowledge, we need to be able to model and understand where our network is going to be stressed, so we can, in some cases, invest ahead of need, or at least increase the level of monitoring in the areas that are likely to have constraints. So again, you see opportunities there in terms of visibility, in terms of monitoring, in terms of understanding customer behaviour, and in terms of having the devices to actually to resolve that issue. And that's where we come into the managing piece. We've got a number of different options here. Storage systems. In the Thames Valley project, we've installed a relatively small-scale subterranean battery, 25 kilowatt battery that goes into our substations to store locally generated energy to be returned to that same network at a later point in time. And is that sort of solution that we're looking for in terms of balancing the network out? Yeah. Now, something that's worth saying as well, it's not on this slide, but one of the things that's a big challenge for us is these peaks and troughs. I was talking about the peaks earlier on. There's some peaks that affect a network once a year. There's some peaks that affect networks every day. There's some maybe just every Saturday. It depends on the nature of the actual network and the nature of the constraint. So we need a whole portfolio of energy storage solutions that can deal with these different time constants. For example, the storage heaters and hot water tanks we talked about could probably move energy between 2 days. They can't do much more than that. Yeah, the big hot water tank can move it across a week, maybe 2 weeks. Yeah, and batteries can move it over a reasonable period, but it's an expensive way of actually moving energy through a long period of time. So we've got another project that we're working on, which is the PATHS project based in Aberdeen, which is a hydrogen project. And what we're doing there is taking the constrained renewables from the network in Aberdeen and turning them into hydrogen. So what we're doing is extracting that excess energy, for want of a better word, once and for all from the electrical network. And where we're putting it is into other areas where it can perform a decarbonising role for the economy. So we're injecting 10% of that hydrogen into the gas mains, which decarbonises gas. Yeah, and we're also putting it into the transport sector as well, working with organisations like First Group and Stagecoach. We're working this project up, and it's currently in with Ofgem for consideration. It's already got a significant amount of European, TSB and Scottish Government funding. So it's and it's specifically going to deal with this long time constant where you start to have to move energy either out of the system altogether or between seasons. And it's an exciting project. And this is where you start to talk about where do all these synergies come from? Where's the opportunity? Well, if you think about that smart grid, BOC is one of our partners on that. Now, who would have thought BOC would be a partner in the smart grid project? They're involved in running the electrolyser for the hydrogen. One of the other projects we spun off with a company called ITM is methanation, which is the next stage beyond electrolysis where you can produce methane directly from electricity. Now, as you can imagine, the potential of that in terms of being able to make sure that your gas assets don't end up as underutilised assets and are part of the solution rather than part of the problem. So what we're trying to do is join up the thinking across different energy sectors. We're trying to involve the right skills and mindsets in there as well to make sure that we've got all these opportunities. And I can't think of a sector that can't get involved in smart grid. We're already talking about appliances and heating systems. We've talked about the gas sector in terms of gas production. We've talked about transport sector. We've talked about all these sort of things. And there's a vast amount of other opportunities out there if we can get into the right form of lateral thinking about the problem that we're trying to solve. So the other projects that are worth talking about, there's a couple of Scottish Power projects. I'm not deliberately left just 2 minutes for Scottish Power. I'm sure they're very good projects. The projects here are kind of showing you how there's some very specific the range of partners that can get involved in these sort of projects. This particular project is about getting as much capacity at the network as possible. So a big element of that is the dynamic rating of assets. Now, it's interesting, there's a lot of crossover here between mathematical modelling about asset management and other sectors. This is about actually using the asset to the limit of its capability, taking into account things like temperature and age profile and all these sort of things. It's also about putting some advanced power electronics into the system to help with voltage regulation. So again, you're getting more out of your existing network. And it's also about flexibly controlling the way the network's configured. So this is why you start to see opportunities in communications. Because to be able to do all these sort of things, you need the communications infrastructure to speak to these devices. These are real-time devices as well, so it's not a low latency system, it's a high latency system. I've got the wrong way around. But it shows you how there's opportunities in the comms sector there as well. And this particular project, University of Strathclyde, TNEI, Nortec, and also the building research establishment are all involved in aspects of this project to actually get as much value out of the network. I hope I've given it justice there, Martin. Good. And another one I think is an important project. It's an interesting indication of what can be achieved with relatively little technology being applied to an existing asset. And it's the sort of thing you'll see a lot more going ahead. And again, you can see the opportunities in here. But this is dynamic thermal rating for overhead lines. And one of the obvious things that, when you think about it, is that the main constraint on overhead lines is they overheat. They get too hot. And when they get too hot, the conductors stretch and the conductors start to lower, yeah? And you start to get issues with, obviously, the lowering conductors. So the thermal capacity of the system is one of the key things. Now, we have basically two ratings in the year, a winter rating and a summer rating that we apply to our lines that determine what that limit is. In actual fact, when it's windy and you've got a cooling effect going on, you could actually get a lot more out of that line than you're actually achieving. So it's a very straightforward principle. I don't think anyone in the room will have any difficulty understanding that. So what this project is about is actually monitoring what's going on in the network. So again, you've got monitoring involved, and there's, depending on which particular model of dynamic thermal rating you go for, there's tension monitoring, there's temperature monitoring, there's all sorts of different things in there. You take that data, you extrapolate that data back, and use that to inform the current rating on your system. Yeah, and at the end of the day, what you end up is, in this particular case, up to 30% increase in capacity on an existing asset, and that can be a significant percentage when you're trying to get additional renewables on an area, and you either defer significant capital investment or actually avoid it altogether in certain cases, depending on the sort of headroom that you manage to achieve. Now, the one key thing I haven't mentioned that's actually appeared in 3 of the projects there is active network management systems, and obviously we've got Alan here talking about from SGS, who've kind of led the development of active network management in the world, I would have said. And there's an active network management system in most of our projects, and the reason for that is that most of these technologies are providing extra headroom. You have to allow, if you're going to get that extra headroom out, you have to allow for the fact that on occasions, on a probabilistic basis, that extra headroom won't be available. And if you can't control the generation in some way, both contractually and technically, yeah, then you're going to bring your lines down. So you have to have a system effectively to enable you to do these things. So most of these solutions, energy storage, demand-side response, dynamic line rating, to get the full value out of them, you need to have this enabling technology in the background, which is your active network management system. So as I say, you'll hear more about that later on, and the way that that's actually developed. And an interesting fact, our Orkney project, which is an up-and-running smart grid project, what we've managed to achieve there, we had the options of a £30 million cable replacement programme to increase the capacity on the island, or an active network management system. We put the active network management system in for £500,000. So it's a factor of 60 lower cost for that. And what we managed to do with that is get 25 megawatts worth of additional capacity on the island. So we doubled the amount of renewables that we're able to get on the island. And what that has done is allowed us to allow the continued development of renewables on the island, while we also work on a more, a bigger solution for the continued demand that there is for renewables on the island. In fact, probably the biggest issue of that project is a success, because we've created a lot of demand and momentum in terms of renewables being connected. But it's an indication of the sort of things that can be achieved. And that saving is savings that the customers in the UK see in their pockets, because they would have been paying for that £30 million investment for that cable, if basically ahead of need. Yeah. So hopefully that gives you a bit of a flavour for the sort of things that we're doing, the sort of opportunities, and just the sheer breadth of opportunities. I've only just touched the surface here. I could talk for hours, but I'm sure you don't want me to talk for hours. So I'll hand on now to Liana. Thanks.
No, they don't work?
Yeah, they work. Yeah.
I see Stuart got applause, but Martin didn't. Do you want to give Martin an applause just so he doesn't feel left out? So you've heard a bit of an introduction to smart grids and a couple of case studies from Stuart over there. What I'm going to talk to you about is how we can try and get the technology into those case studies so that we can spread them across the network. And a novel approach, I suppose, that we're taking in Scotland in terms of organising and managing the resources and the research facilities we have. So what are the innovation challenges? I think smart grid is a headache for the utilities, and it's clearly a vital requirement for the low carbon network economy vision to take place. One of the biggest challenges is how do we increase the amount of distant renewables which are not generating on a consistent basis, and at the same time introduce low carbon technologies at the user side without affecting the reliability and efficiency of the electricity supply, and indeed not affecting the quality of the supply or the required consistent base load for industry to flourish. One of the biggest solutions that has been seen in the last couple of years, as Martin pointed out, is introduction of... Have the lights gone down? Oh well, it's like you're getting boring. We're going to sleep. You're not good looking. It's the introduction of disruptive technologies. Now, introduction of disruptive novel technologies into the electricity sector imposes a very interesting change in the way the industry has operated. In the past, the suppliers and manufacturers of the equipment for the utilities have been big corporate entities. The introduction of these novel technologies allows for small SMEs and startups to introduce themselves into a market which is not accustomed to dealing with small companies. This poses a lot of challenges in addition to the standard policy challenges we've heard about throughout the last couple of days, and regulatory challenges and business case challenges. That's the fact that these small little companies do not have a brand identity within the industry. They have, in general, novel technology with a very poor maturity. It hasn't matured enough. And they don't have capital to invest and demonstrate. Everyone who's been in this industry as well knows that if you're trying to demonstrate a technology on a real network, it's like watching paint dry. It just takes ages, and the network is static, and nothing happens, and you just wait and wait and wait, and hopefully in a couple of years' time something happens. Now, if you're trying to introduce a novel product into the market and you're an SME, that's just going to effectively kill all your opportunities. So one of the things we are trying to introduce within Scotland is a method to accelerate all these novel technologies into market, de-risk the technologies, increase confidence within the utilities and within the energy sector, and test them out and bring them fast into the market so that they can create an economic impact. One way which this is being done is through a concept called the Scottish Energy Laboratory. The Scottish Energy Laboratory is, I believe, 48 different research facilities around Scotland, which take advantage of all the various geographies and environmental situations around Scotland to make the most out of the research. All of these facilities are not only joined and work collaboratively, but more importantly, they are connected. And by connection, it means you are capable of exchanging information. So, for example, I'm in charge of the one at the top. I put it at the one at the top because it's mine, which is a new Power Networks Demonstration Center, which is a 11 kV network. This 11 kV network is connected to 2 other research facilities spread outside Scotland, outside the region where the network is, which is Myershill, which is a wind generator turbine research facility, and the BRE Innovation Park and the Ravenscraig facility, which is another project which Scottish Power are developing as part of one of their case studies. This allows us to link offline, i.e. not affecting the daily operations of the network, generation, final utilities and network and trial novel technologies without having possible negative impacts on the final customer, the final user, and indeed on the network, i.e. causing outages that might affect industry and cause penalties for the network operators, which we see here. So how do all these centers work, and more importantly, how does my center work? So it's an initial funded center. It was funded by Scottish Enterprise, Scottish Power and SSE, in what do they call them? By trilateral agreement, i.e. public money, private money, and academic input. It's a 9 million center which hopes to provide the infrastructure for SMEs and startups and indeed big corporate organizations to trial in a collaborative fashion, i.e. exchanging knowledge and information between them. Now, it's a £9 million center, and many people say, okay, so if it's a £9 million center and it's enabling research, why don't you just give me the £9 million and I'll do the research on my own and I'll take it to market? Now, the reason for this is there's something known as the value of death, right, in the innovation. How many of you have heard about the value of death? Right? So, okay, so I'll explain it to you, even though a couple of you have heard it, so I apologize for those of you who have heard it. So there's a lot of funding being placed in the initial research. Initial research is very high risk, and hence governmental bodies, national, regional, and European governmental bodies are happy to finance that part of the research. Then you've got the development stage. Similarly, high risk, very relatively easy to get funding mechanisms into it. Now, once you finish your development stage, you go into the demonstration stage. That demonstration stage starts from a high risk and ideally, if you've done your research and development correctly, ends up in a low risk, which starts to impact your bottom line. So as soon as governmental agencies see that it has the potential of impacting the bottom line, the amount of funding into the demonstration side reduces. And hence, small companies are unable to break that barrier and get into the final deployment incorporation into the product base. And so what we're trying to do here is we're trying to pull all the resources together from utilities, provide a good infrastructure for all these technologies to be tested on a real case scenario and accelerating the scenarios. So effectively we can run 1 year's worth of scenarios in probably a month or two, depending on what type of scenarios. So we can get the technology into market much faster than we would in any other type of situation. So succeeding, yeah. So the basis for all of this is we're trying to succeed. People have been talking about smart grids for a very long time. However, smart grids is still on its infancy. There are very strong opportunities out there, both to develop new technology, to market it, and to export it, and hence to create jobs and to have a significant impact on the knowledge leadership, global knowledge leadership, which is perceived as a requirement for sustainable economic growth. So we think we can, by pulling our resources together, we can affect this impact. If we go, how much time do I have left? 2 minutes. Okay, so I won't go there. So if I don't go there, there are major energy challenges, which we have heard for the past 2 weeks, for the past 2 days. I've heard it for much, much longer, like 13 years. But anyway, that's all right. Maybe you've heard it in a concise form for the past 2 days. Ahead of us. And we need to meet certain carbon reduction targets in the next couple of years. In order to meet these carbon targets, we cannot just consume less. And we cannot just drill more. At this stage, we cannot drill more, and we cannot bomb another country either. So the only alternative is to go the classic way and innovate. And innovate in this economy costs money, so we really think we need to do it together. And we need to do it together in trustworthy scenario where we all belong to the same entity, which is what we're trying to create here. So, having talked about collaboration and talked about the great impact that new technologies can do, I'll leave you with Alan, who's one of our successes. Not mine, but I suppose Scottish success.
Thank you.
He's Scottish, I'm not, so clearly he can't be mine.
Thank you, Ileana. As Ileana said, what I'd like to talk to you about very briefly is the story of our company and how we've managed to find opportunity within this sector, and why, for us, being a part of the clean tech world is a key thing for our business. So, just to give you a quick introduction, we're the UK's leading smart grid software and technology implementation company. We basically blend people who understand power networks and power systems with those that come from the ICT world of critical national infrastructure. We formed the company in 2008, but actually the story starts 5 years before that. So 10 years ago, in 2003, a gentleman called David Telford, who actually now heads the control room in SSE, but at that time was head of network planning, basically was looking at the issue of connecting lots and lots of wind in the north and west of Scotland. And issues coming forward with how do we plan and build an electrical grid that can transport that energy from where it's been generated in fairly remote rural sites with very sparse electrical infrastructure to demand centres. And projects like Beauly Denny and all these things were getting kicked off, but everyone was understanding there's a significant challenge with those projects, both in terms of the cost and capital involved, in terms of the time and planning issues involved, but also in the sheer environmental impact of rebuilding lots of electrical grid infrastructure. And we knew in reality that all generation and demand is changing at any point in time. In this situation that Stuart talked about earlier, where in essence the trigger in an electricity grid to rebuild an entire section of line or a new substation can simply exist for very small periods of time in a given year. So this is where it started, and it kicked off as a research project in collaboration with SSE and the University of Strathclyde, looking at the technical and commercial challenges about how grids could actually change the way that they've been planned and operated since the 1950s. That project basically got to a stage where the proof of concept, the pilots had been undertaken, and everyone understood this was in theory possible. And I got involved, and I'm one of the co-founders of the business with the academic team at the University of Strathclyde, and we spun out that intellectual property into the company. Now, the bit that's not on here, because our shareholders are Scottish Equity Partners, the university itself, Scottish Enterprise through the co-investment fund, including the team. But actually, the initial investor was SSE in their venture capital business. And the reason that was so important for us, because of this challenge that Ileana was talking about, how does the major barrier in the industry for a new technology to make it is really to get a reference site. How do you trust someone whose fundamental reason for being is about keeping the lights on to let you try a bit of technology on that network? And that barrier, whether you're a small company or whether you're GE, is just as large. And we worked with SSE from the start and basically worked with their venture capital team, because actually the money was only part of the reason for doing that. We needed a reference site for our technology, almost far more than the money itself. We've used that, and Stuart talked about the Orkney Smart Grid, which was the UK's first smart grid, and we deployed. And that's given us as a company a platform to develop more applications and find more solutions for the industry and tackling these issues about low carbon within the context of smart grid. And we've grown in 4 years to 30 people. We were named the second fastest growing clean tech company in Europe last year, and also by Bloomberg New Energy Finance as one of their new energy pioneers. So this is recognised both in the UK as well as internationally. Fairly complex slide, but in essence, what you have on the left-hand side is this situation that Stuart was talking about the extent of grid capacity. This is what we do. The capacity in the grid is typically only utilised because we keep a certain amount back for faults, outages, low probability events. And actually, if we can understand those things and we can interact with controlled devices on the network, whether they be generators, demand, or indeed energy storage, we can actually greatly increase the utilisation of that grid infrastructure. And indeed, through things like the meteorological data that Stuart also talked about, we can actually extend beyond what the current use of the grid is. And it's our software that sits at the heart of this. And we have 5 applications on the right-hand side here that do that. And ultimately what that means is it allows our customers, some of them are here today, to basically provide their customers, so the people developing projects, whether they be shopping centres, whether they be wind farms, whether they be any other form of generation capacity, to provide more cost-effective and timely connections, because we don't need to wait for huge network upgrades and planning issues and raising the capital to do that. Well, we allowed that network to significantly avoid or defer big capital projects, and it allows those assets to be maximised. So the thing that underpins all of this, however, is actually the regulatory environment. And so the networks businesses are natural monopolies, and they're regulated by Ofgem. And actually what happened when the industry privatised, I think I must have been incredibly young then, because I don't remember the specific day. Basically, it started to take money out of the system and to make everyone's bills cheap. And we've all benefited from that. But one thing it did do is it took innovation out of the system. So the R&D centres that used to exist basically all stopped. And back in 2005, Ofgem recognised this and started to create funding mechanisms for the network operators, Scottish Power and SSE here, to start to look at ways to innovate and to fund that innovation and fund trial projects. And so the successive regulatory settlements from them have actually built up an increased amount of funding available for that. And that's really where the UK has actually taken a real lead, not just in a European, but actually in a global context. Countries around the world are looking at that environment and saying how good it's been in actually trying to deliver change in the way electricity networks can be planned and operated. But for a company, it's provided a fantastic opportunity for us to develop technology and solutions which can have reference sites and technology demonstrations funded, as well as build up a customer base which we can now export. So we are working into Europe and into North America aggressively. And actually those countries are coming looking to the UK because we've got the proven technology. Well, what a wonderful opportunity that is. And it's because of actually this regulatory regime that's existed for the last 10 or so years. And what it means to us now is that we want to grow. So there's a new regulatory environment coming in from 2015. And actually, what's significant is Ofgem are now saying, well, you guys have had money, you have had a chance to innovate. We want to see those innovations turn into business as usual. We want you to roll out these technologies that are bringing benefits to the customers and the bill payers. And that's a huge opportunity for a business like us. And in Europe and North America, they're looking to the UK for these proven solutions. Again, a huge opportunity for a Scottish business. And for that, we as a company are able to develop our products and our solutions and our capability to deliver at that scale. And that's really the challenge for us going forward in the next few years, is actually to take advantage of that situation. So hopefully that's given you a flavour of some of the challenges and how as a company we've been able to create a very fast growing clean tech company in the smart grid sector here in Scotland. I'm going to hand over to Josh, who I'm sure will give you some of his own story of growing Symetrics. Thank you.
Thank you, Alan. I've got only a few minutes to talk about a 14-year journey. I won't bother asking how many minutes I actually do have. But Symetrics is a Scottish company, it's in Edinburgh, and we in fact had a very wobbly start, but not perhaps for the reasons you might think. In the mid-90s, the power system in the UK was being challenged in that utilities in Scotland wanted to be able to export as much energy into the English market as possible. But they were being constrained because they were getting oscillations occurring on the system. So these were very low frequency oscillations. It's quite a technical area, but it means that you get huge amounts of energy rushing backwards and forwards from one end of the country to the other. And if these oscillations grew, as you can see here, basically it would cause protection equipment to trip and people would have a blackout. So it wasn't acceptable. Now, the way the system worked then was that you would be modelling what was going on, and then from your models you would adjust how much you could securely transfer over the interconnector. And these models meant that they had to have this constraint in place. So we came across this issue from discussions with some of the engineers at Scottish Power, and wow, it was a fantastic challenge for us. And so we asked them for some data, and we went away and we basically came up with some technology which would allow us to, from measurements made on the system, provide an indication of how stable the system was. So that basically the idea being that rather than rely on their models, they would actually rely on the measurements and basically would be able to securely increase the transfer levels. So we presented what we came up with to Scottish Power, and they very kindly agreed to buy the finished product. So we had to get from this concept, this idea, to a product. And certainly there wasn't the funding opportunities that there are now available then, but we were able to leverage the Scottish Government innovation funding and some other resources, and we ended up producing a system, and it was placed on the Scottish Power Network in 1995. And that and some other measures allowed Scottish Power to be able to increase power flows by some 300 megawatts. So it was quite a significant advantage for them. And because of the success there, it also got the attention of National Grid, and they very soon also bought their own system. And for the last 14 years or so, they have had the system in their control room in Wokingham, and they have it connected to a set of traffic lights in the control room so that the operators will actually have a visual indication of whether there are severe oscillations or not on the system. So from this start, with 2 customers, we developed some custom hardware because we couldn't get the measurement technology that we needed off the shelf, and some special software. How did we go from there to having customers all around the world? And that's also been quite an interesting journey, because initially we weren't really sure what the market was like. We basically knew from the physics of systems that if you had long transmission lines, you're likely to have oscillatory problems. And this led us to present papers at various conferences and so on. And the next customers that we got were basically about as far away from the UK as you could imagine, and that was in Australia. And basically they had some issues there where they wanted to be able to, for the first time, connect electrically 2 parts of Australia, New South Wales and Queensland. And the transmission line was going to be over 1,000 kilometres, and they were very concerned about the possibility of oscillations hampering the success of that project. And so they used our technology to be able to manage the commissioning process, and that went very successfully. And they were also then able to use our technology to release, as it would happen, another 300 megawatts of capacity on that line. So without our technology, they were stuck at some 700 megawatts. With our technology, they could raise it to a full 1,000 megawatts. So this was, you know, a very good reference for us, as was Scottish Power. And basically, we were then in a position where we had this sort of very, you know, we owned the sector, if you like, but there weren't that many customers for it, it would appear. And part of the barrier was that the specialist equipment that we needed to put in place, and we were also having to do hardware, and we didn't really feel we were adding any value there. And in about 2005, the industry adopted some new standards for synchronized measurements. This is the synchrophaser technology. And we recognized that that was a big opportunity for us. And so we abandoned our own specialized measurement hardware and adopted the protocols for these new measurement devices. This also had the advantage for us in that it actually allowed us to expand out the applications and the benefits that we could deliver to our customers. But we already had the experience with a wide area monitoring platform, and we were able to very easily bring in these new measurement technologies. So we had the change there in the industry, and at that time we also looked to strengthen our team. So we were very lucky to be able to secure Robin McLaren as chairman, who had been previously managing director of Scottish Power's transmission and distribution businesses. And we also, for the first time, brought on board professional sales person. So we were also starting to see changes in the industry, because before that things happened very, very slowly. People didn't perhaps understand the technology, but with all of the regulatory changes and increasing pressures there was much more interest in how you could actually get more out of your existing system. So for us, the technology developed into solutions that allowed the utilities to increase the security of their systems. In other words, to be better at avoiding blackouts, and also to be able to get more energy down their existing networks, and also to help them understand the behaviour of the networks in terms of their modelling, and also to be able to help them connect more renewable sources onto the network. But the area we're working in is quite a complex area, and we realised that one of the issues was that a lot of utilities weren't really understanding or have the skills to be able to adopt the technology. And so we basically made available, if you like, a services offering. And this really came about where we were talking to a prospective customer, happened to be in Iceland, and they weren't interested in the kind of monitoring that we were doing. What they wanted was a solution to some stability problems and some help in being able to connect new generation onto the system. And in their case, they were looking at a new hydro plant and a smelter. And the size of that hydro plant was equivalent to 40% of the then installed capacity. So it was a massive change on their network. And basically, we proposed to them a solution where we would actually resolve the stability issues using our tools and help them connect the generator and the smelter. And that went very well. In fact, we installed our system. We told them it was for our use only, but they were rather intrigued as to what we could see about their system on this. And after a while, they asked if they could actually start to use it, and we said, okay. And a few months later, they basically said to us, we actually don't know how we can manage our system without your phaser point solution. So that was a fantastic reference, and they've been a fantastic customer to work with, and have helped us to develop a range of new applications, so that we're now moving into also the control area for wide area defence schemes. So it's automatic control, and again, this is a very difficult area to be able to get utilities to adopt. When we talk about control, there's a lot of challenges there. But we actually have a prototype system that's now deployed in Iceland and things moving forward there. So that's very exciting for us. So from those successes, we moved on. We also looked at partnerships, because we spent quite a lot of time trying to sell our solutions in the US, and we got lots of enthusiasm and very little money, and we did pilot projects, but we didn't actually get a full sale there. And we didn't have the resources to be able to establish our own office and have a credible US operation. So we decided that we would just look for the appropriate partner and work with them on that. In various events and industry we went to, we basically started bumping into people from what was then Arriva T&D, is now Alstom Grid. And they recognized that what we had filled a gap in their product portfolio. And we decided that if we're going to do any partnerships, the first thing to do is to see if we can win some business together. And so we basically partnered with Alstom, and we won what was then the world's largest WAMS project in South Africa. It was a €3 million project. And that's now in this deployment phase. It's a very large system. So that was a huge success for us, and also validated our partnership with Alstom. We then went on to work with them to win an energy management system contract in Sweden. And this resulted in last year, when we became acquired by Alstom, and we're now Alstom Grid's Centre of Excellence for phaser-based applications and online stability. We're kind of working on a better title than that, but it's a bit technical. And so, just over a year ago, we had no presence in the USA, we had no customers in the USA, and today we have something like 1/3 of the US population now covered with our solutions. So our solutions basically cover 1/3 of the US population now. So that's in about less than a year. So I guess that the key things for us have been that we've been lucky enough to have a great team in the business. We've also been able to focus on producing solutions that are useful and are beneficial to the industry. And we've also been incredibly persistent. So that's how we've got to where we are today. Thank you.
Thank you very much, Joss. I hope that this session's kind of given an overview of some of the successes, just as Joss was mentioning there, as well as kind of providing scope for some of the opportunities I think that are coming up over the next decade and beyond as we go through this low carbon transition. I think we've got only maybe a minute or two left. I could probably take time for maybe one question. If not, I think all the panel members will probably be around for coffee anyway. Yeah, please.
I mean, I think here, Max Kailulum. I'm interested. I mean, you talked about the technical challenges and the need for test centres. That's absolutely, key to being able to demonstrate a technology and all the rest of it. But one of the key things, of course, is knowing what you could sell a product for. And you illustrated the example of Orkney, where a £500,000 investment effectively saved £30 million of £25 million of investment. So the value of it is anywhere from, So how, let's say for the sake of argument, I've got a technology that could produce, it could be an energy storage technology, 1 megawatt hour, say. How can you quantify that? How can the utilities give the right signals as to what it's worth to you, given the avoided network infrastructure costs and that kind of thing? Obviously, you've got peak and power and stable power, and you've got storm mechanism. But how can we develop this? What signals are you given? What incentive is there for you to avoid that cost of putting a cable in? Because you could have just put a cable in, I guess, and got a regulatory return.
Yeah, absolutely. I think a good example of that is the storage heaters and the hot water tanks that we're putting in. What we've done is we've used the LCNF funding mechanism to give us a platform which to fund the development, do the trials and validate the value. We placed a value of £200 per household on the value of that system per annum. So we use the LCNS to validate that. In terms of being an incentive, the Rio debate's still going on at the moment, obviously, but it's pretty certain that a company that goes for the kind of traditional stick the cable in the ground will not be making money out of Rio. You know, if another company is using a more innovative approach to solve the same problem, so you know we're anticipating the innovative solution to be the benchmark. Now there will be some that after evaluation don't actually meet that benchmark, the others that do, and that's the whole point of the LCNF, is to give you that opportunity to do that assessment. You know? So I hope that answers. Yeah.
So as I say, we're very tight for time. I realise there's only a short break before the next session. As I say, I think the panel members will all be around at the coffee break. If there are any further questions, please feel free to approach us. And I was asked to pass on instruction. I don't think there's any formal announcement about the next session starting. So I think if you could please be in the rooms for 3:10, which is when the next session will start. Thank you very much.